mention who the winner this week is for the idiot honor roll. Talking about idiots, hey, we have the idiot honor roll, and it was a big competition this week. I mean, people tried very hard to win, and I gave it to this fellow only because he mentioned something that several people have mentioned along the way. We have a little history on this issue, and so I thought I'd put him up there in lights so that people understand it. Okay, so what did this fellow say? Let's see if I can get this here. Give me a second. Okay, fellow says, in the rope theory, okay, not a theory, it's a hypothesis, but okay, what is the explanation for the cause of the pull down to the earth? Okay, if everything is connected by ropes, electromagnetic ropes, right? Why is it that all the ropes that connect to other stars, planets, don't also pull on objects? Okay, there's several people who said, they said, when a spoon falls, I say, well, because the spoon is connected to every atom of the spoon is connected to every atom, in the earth that comprises the earth. And so the question is, they say, this fellow says, well, how about the ropes that connect us to everything else in the universe? Don't they pull the spoon upwards? Should they? And I guess that's why he won the prize this week. Okay, so let's go slowly for those who have problems. Now, there's two possibilities. The fellow either jumped the gun, okay, and just asked the question without thinking, or maybe he actually doesn't understand and it's simply an ignoramus. I guess he never went to high school, because in high school they teach you something called mathematical physics, okay? And one of the first things you learn is Newton's equation. Don't they understand it? Newton's equation, don't they relate to it at all? Okay, so this is what it's all about. Here you have the Earth, the moon, and an astronaut over there on the right. Okay, and the astronaut's close to the Earth. Okay, and so the question is, who would he be attracted to the Earth or the moon? You might say, well, to the Earth because it's bigger, it's got more mass. Okay, that's what Newton's equation would say. But how about the distance? Like under the rope model, you have all these connections from the astronaut to the moon, to the Earth. Okay, and you also have connection from the astronaut to the moon. Okay, and here it is. Okay, so he's connected to both the moon and the Earth by electromagnetic ropes. But now you look at the equation, and hopefully you should be able to determine that it's not mass that's the big ingredient in the equation. It's that distance squared on the bottom. Distance plays an enormous role in that equation. The more distance you have, mass can become even almost irrelevant. It doesn't matter how big the mass is if it's on the other side of the universe. Okay, you will have no effect on that mass because the distance is so great. And here you have, for example, in this case, you have a star, okay, and it's far away, okay, and every atom in that star is tied or bound to every atom in your body, in every single atom. They're all connected, but they're so far away that you can almost consider all those ropes as a single coaxial, as if it were a single thread. It's got very little influence to you, even though every atom in your body is connected to every atom of that star. And the reason you can see the star is that you're looking along the ropes. In other words, the rope torques from that atom in that star to an atom in your eye, and that's why you can see it. Otherwise, how do you think Mother Nature does this? Does it do it without anything between your eye and that star? Are you saying that we have this faraway star, it's sending little photons to your eye? Don't those photons swerve in space? Okay, don't they turn around the corner? According to Einstein, you've got all these potholes caused by gravity. And shouldn't those photons just go in every which way except straight? Okay, so here we're saying, no, you have a straight line of direction to that star, and you have it through the ropes. So you have, this situation. I'm connected to every atom in your body through the ropes. Okay, so the ropes are always taut. They're tight, okay, pulled tight, not flexible. Okay, all they do is torque in place. That's why they're so fast, because torsion is the fastest thing known to man. And so that's our theory. But yeah, you have to apply Newton's equation. And for that, you got to look at distance. So yeah, people who ask that question can look at the honor roll, and maybe they'll find their answer there.